Hello everyone, welcome to the next lecture in the computer network series, and today we will see addressing in networking. This lecture is created in order to help you to understand things in a better way and in a practical way. So we will see the outcomes of today's session now. Upon the completion of this session, the learner will be able to understand the role of port addressing, IP addressing and MAC addressing in computer network with examples. We have already seen port addressing, IP addressing and MAC addressing. Now we will understand how these addresses help in order to take a packet from the source computer's source process to the destination computer's destination process. We have already seen this example in the previous lecture. Suppose if this is the sender computer and this is the receiver computer, let us assume that A is the IP address of the sender computer and P is the IP address of the receiver computer. And in the sender computer, there are three processes running, 1, 2 and 3. And this process is assigned with the port number A, this process is assigned with the port number B, and this process is assigned with the port number C. And similarly, in the receiver computer, there are two processes running, process number 1 and process number 2. And this process is with the port number J and this is with the port number K. As I told you, this is the sender and this is the receiver. As far as hosts are concerned, A is the sender computer and P is the receiver computer. The data that is generated by this process in the sender computer with the port number A must reach the receiver computer and this process, that is the process with the port number J. So what happens? The sender computer's application layer generates the application layer data. So this application layer data is generated and it is then given to the transport layer. So I am ignoring the presentation and the session layer because the intention of this lecture is understanding port addressing, MAC addressing and IP addressing. In the transport layer, whatever the data that is received by the application layer, it is added with the source port number and the destination port number. The source port number is A here because this is the sending process. And the destination port number is J here because this is going to be the receiving process. After adding the source port number and the destination port number, this information or this content is given to the network layer. With that information, the source IP address and the destination IP address are added. In this case, the IP address of the source or the sender is A and the IP address of the receiver or the destination is P. And these additions are done in the network layer. Then this entire content is now given to the data link layer so that the data link layer adds the source MAC address and the destination MAC address. So source MAC address and destination MAC address are added in the header and error control related things are added in the trailer. Let us not talk about this now. Now the entire content is converted into zeros and ones and then it is given to the router. This router will forward to other routers in the internet and finally it will be received by the destination computer. So destination computer sees the MAC address related things in this part, IP address related things in this part and the port number related things in this part. The information received is with the destination port number as J. So this computer knows to which process it should hand over. So it delivers the data to the process with the port number J. That's the working of port addressing and IP addressing. So port addressing related things are done in the transport layer and IP address related things are in the network layer. To make the things easy to understand, I have used the source port number and the destination port number to be A and J. But in reality, source port numbers and destination port numbers will be in 16 bits. And if it is the IPv4 address, it will be in 32 bits. Source IP address will be 32 bits and the destination IP address will also be 32 bits. If it is IPv6, then the source IP address will be 128 bits and the destination IP address will also be 128 bits. Anyway, we will be dealing about this IPv4 and IPv6 elaborately in the network layer part of our series. For time being, you just understand that IP addresses can be IPv4 or IPv6 and port numbers will be of 16 bits only. Now this example helped us to understand about port addressing and IP addressing. In the next example, we will see IP addressing and MAC addressing. Now we will see how IP addressing and MAC addressing are dealt in the network. Suppose if this is the sender computer and this is the receiver computer. Now we are not focusing on the port numbers. We have already seen examples with port numbers. Now we will focus only on IP address and MAC address. Let this be the IP address and let this be the MAC address. Similarly, every node will have this IP address and MAC address. For this interface, this router has two interfaces. One is here and one is here. So this is the IP address and this is the MAC address. Similarly, this is the IP address, this is the MAC address. This is the IP address, this is the MAC address. For this receiver computer, P is the IP address and 95 is the MAC address. Actually, IP addresses are the 32 bits if it is IPv4 or 128 bits if it is IPv6, but MAC addresses are of 48 bits. For understanding things in an easier way, I have not used actual IP addresses. Now, if this sender computer wants to send the data, this is from the IP address A, computer's interface is having the MAC address 10. The application layer generates the data, then it is handed over to the transport layer, which is not dealt in this part. Now it is going to the network layer. In network layer, source IP address and destination IP addresses are added. So we know very well that the source IP address is A. So this is added here. This is the source IP address. So first part in IP is the source. And we know that this is the receiver computer and the destination IP address of this receiver computer is P. So we have used P here. So after adding the source IP address and the destination IP address, it goes to the data link layer. In the data link layer, with this data, you could observe that this data is here. With this data, header and trailer are added. We know that in the data link layer, header and trailer are added. In the header, it will add the source MAC address and the destination MAC address. We know this is the source MAC address. So this is the source MAC address and the destination MAC address. If you observe, this is actually the destination MAC address. But this is not used here because in all the cases in our networking, we will never try to communicate using MAC addresses. We will leave the computer networking to take care of MAC addressing. We will always communicate with other devices with the help of names or IP addresses. For example, if I want to access google.com, I will open a browser and I will give www.google.com as a request. Or if I know the IP address of Google, I can communicate with IP address. But we will never give MAC address for communication. So what this computer does is that it knows what is the default gateway for entering into other network. For example, this is a local area network. Let's imagine there are 100 computers or n number of computers, and this sender's computer is one of the computers in local area network. When this computer wants to send some data to other computers in other local area network, it has to hit this part, this router's, this interface. So what is the MAC address of this interface? It is 20. And what is the IP address of this interface? It is F. So this computer is aware of this part and not other parts. So this computer, what it does, it uses the source MAC address as this computer's MAC address, that is 10, and the destination MAC address as this router's MAC address, so which is 20. And this interface is normally called as the default gateway because this is the entrance for this computer to reach other network. Now once the packet is received by this router, it opens the packet, it collects all the information in the physical layer. Now if you observe what is received by this router, it receives the data which is appended with the header and the trailer. The header says this is the destination MAC address 20 and 10 is the source MAC address. Yes, this is the source MAC address. And 20, yes, this is the destination MAC address. But IP addresses are different. So A is the source computer's IP address and P is the destination computer's IP address. So it collects all the physical layer information and constructs the data link layer part. After receiving the data link layer part, it opens and sees what is the destination MAC address. And this is the destination MAC address. So this router understands this packet or this information or this content is for this router. And it again opens the network layer information and it finds a different destination IP address. So actually the destination IP address is P, that is this computer, but the destination IP address is F in this case. So it finds a destination IP address. So router concludes that this packet is not for this router. So this router concludes that this packet, though it has its destination MAC address to be 20, but this is not having the destination IP address as F here. This is P, that is it is some other computer. So what it does, it removes this source MAC address and destination MAC address and puts a new MAC address in this part. So if you observe, so this is the outgoing part of this router now. The information is received this way and this packet leaves this way. So F bar 20 is the entry point and T bar 99 is the exit point. When it leaves T bar 99, and what is the IP address of this interface? It is T. So we are not cared about IP address now. And what is the MAC address of this interface? It is 99. When the packet leaves this interface, now this is the source MAC address and the other router's incoming interface, that is this interface, and this is the destination MAC address. Since they are adjacent routers, it can learn about the other router's MAC address. So it uses this 99 as the source MAC address and 33 as the destination MAC address. And we observe that these physical addresses are changed during transmission. So this is now 33 and 99, which means 33 is the destination MAC address and 99 is the source MAC address. After this data is received by this router, it opens the content and sees, and it finds the destination MAC address to be 33. Yes, this is the destination MAC address, and it goes to the next layer, that is the network layer, and it finds the destination IP address to be P, but actually this router's IP address is N. So this router understands that though it is having the same MAC address, but it is not the same IP address. Since router takes decision only with the help of IP address, so it forwards the data to this interface because this is the outgoing interface. So once the packet is sent this side, in this side if you observe, this is the source MAC address, that is the MAC address of this interface. So this interface MAC address is 66 and the destination MAC address is to be 95, that is the receiver computer's MAC address. Yes, this is the destination network. So this router knows what is the destination computer's MAC address. So what it does, it puts the destination MAC address in this place and the source MAC address to be 66. So it uses 66. And finally, the data is received by the receiver computer. When the receiver computer receives this packet, it sees what is the destination MAC address. Yes, this is this computer's destination MAC address. And then it goes to the next layer and it finds what is the destination computer's IP address. Yes, this is the destination computer's IP address. So this receiver receives this packet and takes this packet or gives this data to the application layer. So if you observe, in the entire scenario, these physical addresses are getting changed. Now you may ask me a question. What if this receiver replies to the sender? If this receiver wants to reply to the sender, so it exchanges these two information. Now 66 is the source MAC address and 95 is the destination MAC address when the packet is received by the receiver. Now it just swaps these two information. Now 95 becomes the source MAC address and 66 becomes the destination MAC address. Again it reverts or it swaps these two information. The source IP address will be A. Instead of P here, A will be used, and instead of A, P will be used. So these two get swapped. And when this router receives this information, it sees the destination MAC address to be 66. The destination MAC address to be 66. And it accepts this packet and it goes to the next layer information, that is the network layer information. It finds the destination IP address to be A, but here the destination IP address is not A. This is Z. So what it does? So it swaps again the MAC addresses and forwards the data to this router. This router again swaps the MAC address and forwards the data, and finally the sender receives this information. So this is what the role of IP addressing and MAC addressing. If you notice keenly that this router is concerned with collecting the physical layer information and constructing the data layer part and checking the data layer part whether it is for this router, and then it goes to the network layer part. So swapping is done only in the physical layer part, but this router also checks the network layer information or the network layer header. So all the intermediary devices like this router will check physical layer information, data link layer information and network layer information. And that is why in the previous examples we used to say that any intermediary node will always process 3 layer information: the physical layer information, data link layer information and network layer information. So when this computer sends the data, it uses this computer's IP address and the destination computer's IP address, but it is different in case of MAC address. It uses this computer's MAC address and this router's incoming interface as the destination MAC address. When this wants to send some data to this device, it changes the MAC address and forwards to the next router. And this also changes the MAC address and forwards to the next router, and finally the data will be received. So intermediary devices, processors, physical layer, data link layer and network layer part only. I hope now you are clear with the role of port addressing, IP addressing and MAC addressing. We have also seen examples. I hope these examples will help you to understand things in a better way. Thank you.